Yeah. So can you see the screen?
Yes, sir.
Yes, sir.
So do you remember what we have discussed in the not last class before Cat 1? Anyone?
We started forging and then we saw different types of forging. And then we did the open die forging and then we saw the numericals based on the open die forging.
Yeah. So when we classified the forging, so in how many types we have done classification?
Three times based on the things are open die and the other two I don't remember the exact one.
Okay. So okay. So anyone, if anyone to share, Amal.
Sir, three types.
Okay. So remember.
Impression
what
and
kind?
flash lift.
Yeah. Okay. Okay. So first one we have discussed about the press, like the force applied. So one is a forging hammer, then or the maybe drop hammer, and the next one is the forging press. Like one is manual and one is the with equipment, right? And the second one we have talked about the based on the temperature, the cold forging, hot forging, or the warm forging, right? These two we have discussed. Then third one, when we talked about the difference, like if another the metal flow, in based on this metal flow, we can discuss about open die forging, impression die or the closed die, and third one is flashless, right? These three we have discussed. And then based on these, we have done the open die forging in detail. We have discussed about some the mechanics, how it is doing or how the process is working. Then also few steps also we have made it, like step 1, step 2, step 3. Then we differentiate initial height and then final height, how much velocity and force you are applying. Okay, so these are we have discussed about the open die forging. And F equal to Kf YFA, then Kf equal to 1 plus 0.4 mu d by h. These are we have discussed, and based on this, you found a few numericals in the exam, right? These are we have discussed. Fine. Okay.
Yes, sir.
Yes,
Then,
sir.
then apart from this, now only one slide it remain. I think I remember. I do not remember whether I have covered this slide or not. So if not, again, just we can make a recap of when we talked about the open die forging. Several other open die forging operations are there. Okay. So here operations classified as open die forging or related operations including fullering, aging, and the caulking. Okay. Maybe somewhere you heard these terms, or maybe if not, then probably I will just put some schematic diagram how actually it works. Okay. So here you can see the first schematic diagram is based on the fullering, and the second one, the B part, this is known as the aging, and the third part is cogging. Okay, so almost like everywhere a little bit of different of the die or the the constant die in the bottom and the moving die on the top normally we are using. Okay, in the forging operation. So the fullering, I put just only one definition here. Fullering is a forging operation performed to reduce the cross section. Okay, so maybe yesterday also we are talking about where it is we are considering much. So where the maximum area you are considering. Okay, so we have to we are not thinking of only the height. We are thinking of the area, because whenever you are pressing, it will expand in area. It is not only reducing the height only. Okay, so you are thinking about the cross sectional area. So the fullering is a forging operation performed to reduce the cross section and redistribute the metal in a work part in preparation for subsequent shape forging. Okay, so whenever you are writing also, you have to write, of course, you are writing in your own language, but also some technical term you have to write. Okay, so one is reduce the cross section and redistribute the metal, because initially your metal shape, for example, the height, let's say the height was bigger. So your area also, like, it will go like in a cylindrical way. Okay, so the moment you are making the forging, so that means you are giving the force and the velocity from the top, because the bottom part is fixed. So you have to redistribute the metal in a work part. Okay, so initially, for example, the height was more. So when you have to press it, or you will press it, you have to redistribute the work part in a preparation for subsequent shape forging, because you have to prepare according to your customer demand. You cannot do that, this one I am just only thinking, so I will do, because then what you will do? You do not have anything. right? Then it is accomplished by dies with a convex surface. You can see here, the dies are actually in a convex surface, right? And the second one, if edging, if you will see different from here to here, from A to B. So what is the basic difference? This is similar to the fullering, whatever the operation we are making in the fullering operation. This is similar whenever we are doing that edging operation, but only the surface or the surface of the die is different. So here in fullering, you are using the convex surface or the convex die, but whereas in edging, you are using the concave die. Okay, so only this is the difference. Otherwise, everything is same. And the third part, you have the edging, sorry, the cogging. So in the bottom, in the C schematic diagram, so it is mentioned that a cogging operation consists of a sequence of forging compressions along the length of the workpiece, along the length. Okay, so you can see here. Okay, so that means maybe I'm not telling that this is similar to rolling, but also in other way also you can tell that this is almost close to. Okay, so that means you are moving the like or maybe you are putting the sample, because in rolling also like this you have two rolls here. Of course, we will study in the next module. We have two rolls. Whenever you are passing your material, so that means it will compress there. Okay, so you will find some reduction of area or also the reduction of height there. So a cogging operation consists of sequence of forging compression along the length. So that means it will find along the length. So here the starting thickness here initially you have, and here the lower die you have, this is fixed one, the upper die is moving. So you are applying the force and volume here. So whenever you are making the cogging operation with respect to the length or the alongside the length, then you are finding the final thickness there. Okay, so you are also reduce the cross section. Okay, but your length will increase because here your height is more or height is higher, but the moment you are pressing, your length will increase, right? And also sometimes also we are talking about if you remember, sometimes we are talking about delta L by L, for example. So also sometimes in some people they are not only telling the cogging operation, they are sometimes telling that incremental forging. Okay, so how much actually it is increasing for example 1 minute or 2 minutes or maybe 1 hour. So they are terming or they are considering as incremental forging. Okay, so sometimes we are calling. Is it fine?
Yes, sir.
Okay.
Yes, sir.
So
Sir, in the
next one.
previous two, sir,
Yeah.
in the previous two, fullering and edging, we are reducing the cross section, right?
Yeah, fine.
Also in cogging, we are doing the same.
In cogging?
We are doing the same.
No, but you are doing along the cross section, along the, for example, here you can see, you are just only pressing here. So that means this much part you are changing, only the die part. But here, this is totally cross section. You can see here, the total path is like, this is moving. So you will find overall cross section, overall. But here you will find only this much of area. Okay, only the die area. You will not find here because this is outside. You do not need to do that one. Okay.
Okay, sir.
Okay. Then the second one, if you will see the impression die forging, if you remember, I put one slide only just, basic hints I have given there, the closed die forging, then open die forging, then also the flushless forging, very one schematic diagram I have just put in the beginning. Okay, so similarly here also in impression die forging, or sometimes also we are maybe I do not know whether I put this word there also not, but you can check. If not, also you can add in the PPT. Okay, so in the impression die forging, sometimes also people they are calling as closed die forging, is performed with dies that contain the inverse of the desired shape of the part. Okay, so you can see here. Okay, so this is the sequence, first sequence and second and third, how actually it is going. Okay, so sequence in impression die forging just prior to the initial contact. So you have the starting work part, and this is the fixed one, and this is the upper one, this is moving. So you are applying with some velocity and the force. This is the starting work part. You have this work part. Okay, and the second one, partial compression, because initially you have to go, or maybe you have to touch that. Okay, so you have to apply and you have to touch that sample. Then the third one, you have to press. Okay, or you have to give the whatever the force you need or whatever the velocity you need, you have to put there. Okay, so what will you will find, because whatever the shape you have, so it will acquire, because whatever the raw material you have or whatever the sample or the whatever the initial material you have, you put there. So you will find the extra material. So the extra material you will recover here, and it will recover as flash material. Okay, so these are not used or these are unused materials, and that material you can take it out. So this shape you will find here, but you will find a waste material here. But if you remember when we had the flushless, if you remember that old slide, so in flushless probably we will cover also, you will not find any flush there or any waste material there. Okay, so this is the basic difference between open die forging and the closed die forging. Fine.
Yes, sir.
Yeah, okay. So you can read also, whatever I explained, thus I put the text maybe before exam, at least you can study this one. Okay. Yeah. So here also, whatever the equations, because in like in the previous equations also we have done f equal to kf, yf and y. This one already you have discussed, but here a little slightly difference we are putting here, because you have to press a maximum so that you will get the flash. Okay, of course, every terms is same. For example, F we have taken here force, then YF also you have taken at the flow stress, then A is the projected area. But sometimes also we have to think about the force. Actually, this is the general force you are applying or the maximum force, because the moment you are applying the maximum force, then only you will get the flash. Okay, for example, if you will not make the, or if you will not apply the maximum force, then you cannot get the flash. So that, like, it will be same like the earlier one part we have discussed in the previous classes. So F here is considered as maximum force in the operation. Whatever the maximum force we are using, that is considered as F, and A is the projected area of the part, because that particular projected area we are thinking. We are not thinking the total projected area. Wherever it is working, that projected area we are talking about, then YF equal to flow stress. Okay, so this is the basic difference. And here also one more, for example, in sometimes when we are asking in the question, because these are actually company people, they have already researched this one. So this value is the already established. So you do not need to calculate, or you do not need to find out how this value came, but these people, they have already done it. So if in the exam, let's say, if you are not finding, let's say I am giving this table for you in the exam, then you have to write. For example, if this is giving us, the KF value, whether you have the impression die forging or the flashless forging. If in case of impression die forging, simple steps with flash, this KF value you have to take as 6. When we have the complex step with flash, 8. But if this is given, then this is fine. For example, if I am putting somewhere simple step with plus 6 already given KF value, then you can consider. If not, probably I will take this table in the question. Then you have to choose which one is suitable for that, suitable for your question. Very complex steps with flash, so you have to take KF as 10. Similarly, the flashless forging we will go. So I put this slide in the beginning so that at least we can compare. So the for coining and the complex steps, in coining it will consider as 6, and in the complex step we are considering as 8. Right? And do you know what is the coining? Anyone guess? No one?
Yes, sir.
No. So how, you are using the coins, right? I told maybe I think in composite or somewhere I told. I do not remember. Maybe I think I told. So the coins what you are using, the coins how they are preparing. So you have a sheet metal. Okay, so the sheet metal, you have some die on the top, and this die you have to punch. You have to give the force, immediately. Then you will find some coins there. The blank coins. I'm not talking about minting. Okay, only the blank coins. Then you will find a net shape the waste material. Then again you can go for this reuse. Reuse means you have to again melt it. Then again you have to prepare a sheet. Okay, maybe we have a slide also. I will show you. Okay, so is it clear up to now?
Yes, sir.
Yes, sir.
Okay. Yeah.
Yes, sir.
So here also you can think about when we are talking about improvement, because every time we are talking about, because for example, if 10 years back or 15 years back, so we are just considering the, the simple forging operation. And also I had, when I was studying, for example, in the, when I was in BTech or maybe masters, then we were afraid of forging, because we will find a lot of noise there. Okay, so every time we are thinking that no, the forging is not good, or maybe extrusion, this kind of work is not good. Only some typical manufacturing process that's good. For example, you are melting something, or maybe the automobile shops. These are normally we were thinking. But nowadays, when the technology, everything we are advanced, so that's why I put this one. So you have to think about how we can improve. Okay, you cannot think that whatever the old tradition, whatever the old books, for example, maybe in 19th, maybe some people, they have published some books that are normally we are teaching or we are studying. But now how to improve that one? Okay, so how to go for a lot of, probably we will talk about or we will ask some foreign professors, maybe they will also give some hints about their research, so that at least you will know that in forging also we can do some research. We should not stick on that old tradition what the people they have already established. So improvements in the technology of impress on die forging have resulted in the capability to produce forging with thinner sections as well. Okay, so every time when we are thinking if thinner section, probably it is very difficult. We cannot make it because we have to take a big sample, then we have to press so that we will find something. But at the same time also you have to take thin plates, more complex geometries, drastic reduction in draft requirement on the dies, closure tolerance, and the virtual elimination of machining allowances. Okay, so that means also at the same time we can, which is impossible, or maybe sometimes we are telling that this kind of work piece or maybe this kind of work part probably we cannot do in forging, and also whatever the requirement our what we need, for example, very thin plates or maybe very thin sections, we cannot make it, and also more complex geometry we cannot make it. So forging process with these features is known as precision forging. Okay, so that's why every time we are, I'm emphasizing that whenever you are doing any research, you have to do much more accurate. Of course, you are good in ANSYS when you are doing some like the solid work, let's say. These are very accurate things. But whenever you do practically also, like whenever you will work in a company or somewhere you will go, so you have to do very precise calculation, very precise samples you have to take. Otherwise, you cannot find this result. So here also we will talk about the precision forging. So common work metals used for precision forging, including aluminum and titanium. Okay, so one is the soft material aluminum you can take, or you can consider also the hard material, the titanium also you can consider. There is no, like, you do not think that only soft material we will make or only hard material we cannot make. Okay, so in the same forging operation, we can take the soft materials as well as the hard materials. So a comparison of precision and the conventional impression die forging is presented. Just you can see here. Okay, so the cross section of a conventional, the first part is the conventional one, normally what we are doing, and B is the second one is the precision forging, how accurately we have done it. So dashed lines you can see here, there are some dotted lines here, indicate the subsequent machining required to make the conventional forging. Okay, so if we have the conventional forging here, so whatever the dotted part here, so you have to make it or you have to reduce it so that you can make it the precision forging. Okay, so from that you can see they can derive this sample. Okay, so here also you can make it. You do not think that only like the thick plates we are making, or only we are just pressing. So with a different die also, what I shown in the previous slide also, with a different die or different whatever the shape you are putting there. For example, in casting, I think you have done it some laboratory probably. I'm not sure. So if you have the sand molding whenever you are preparing, so according to your mold size or according to your mold shape, you can prepare accordingly. Whether you are making a rectangular or maybe triangular or maybe star kind of structure, or maybe any different kind of structure you can put it. Okay, but also that depends upon your other properties as well. For example, your melting, whether this is liquefied or not. Maybe sometimes like we are taking from the furnace, but this is not liquid, but still we are pouring. In that case, you will not find. And your weather, okay, how much time it is taking for the solidification. Okay, so these are, I think you have already studied, but here also in forging, whenever we are talking, you have to compare. Okay, just you can compare whatever this size and this size. You can see the precision now. Okay, whether this precision is good or maybe this precision is better from that, right? Also, you can make it in forging. Fine. Okay. Yeah.
Yes, sir. Yes, sir.
Yeah. Then the next one we have the flushless forging. Can somebody tell maybe this one slide I have put? What is the flushless forging and the the with flush forging? What is the difference? Anyone? Just guess. You do not need to tell technical words. Just in your language you can tell. Or from the schematic diagram you can just tell. You have the screen now.
So
In flash,
Yeah, one by one.
There's no excess material coming out of the die also. All the
Why?
material because we are enclosing the entire work material
Yeah.
in all
Yeah.
directions.
Yeah. Okay. Okay. Anyone you want to share? Somebody was telling.
it was the same, sir. It's covered in all directions, so there is no way to let the material out.
Yeah. Yeah. Okay. Okay. Fine. So here you can see the impression. Yeah.
More force is required.
Yeah. 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 Again, tell please.
I think more force is required in this.
More force is required. Yeah. Yeah. Okay. Okay. Fine. So here you can see the impression die forging is sometimes called closed die forging in industry terminology. Okay, so this depends upon, because in books also if you will see, so many times like the terms are different. So if you will, maybe it was interesting that when I was actually checking few papers yesterday, all the students, for example, the when we talked about the critical resolve surfaces, everybody considered theta and phi, but I think one student he wrote gamma. So I probably he studied the book, I think, but it is also requested to find some books, because I have shared, I think, or maybe if not, then probably I will share. So you can read some books, because sometimes like in manufacturing, some people they are more fond of the metal forming, because many research also people they are doing. So I think last time, if you remember, the professor actually he talked about the machining also. He was doing research in machining. Okay, so also if metal form, because we are learning the study theory part only, so that's why probably I do not know whether you felt a little we can make it some research or not. So that's why I just presented one slide that how people they can make it from the traditional, how they can make it some difference. And this is more similar to what you are doing in the solid work, like the ANSYS or something what you are doing. So if you can project, then maybe you can make a group, so that some people they can work in experimental as well, because some people they are fond of the simulation kind of work. Some people they are interested in experimental work. So the college is open soon. So probably you can think of whether it is possible to do or not. If possible, then you can go ahead. Okay. So however, there is a technical distinction between the impression die and the true closed die forging. Okay, so you have to think about what is the basic the mechanical aspect or the metallurgical aspect, whatever we have. So we have to find out the technical difference between these two, what are the flash forging and the flashless forging. And the distinction is that in closed die forging, the raw workpiece, okay, whatever the raw workpiece you have is completely contained within the die cavity. Okay, so you can imagine whatever the die cavity you have initially. Okay, these are the difference you have to write in the beginning. Okay, so whenever you are writing your note, I do not know whether you are preparing a note or not. So if you are preparing, then you have to write, because everything I put there. The first distinction is that in a closed die forging, the raw workpiece is completely contained. So that means your the die cavity is bigger and workpiece will completely inserted there. It's completely contained within the die cavity during the compression, and no flash is formed. And second one is no flash will be formed. Okay. And the term flashless forging is appropriate to identify the process. Okay, so you can see in the second stage what is happening. So the flashless forging just before the initial contact, okay, initial the first starting point, and the second one is partial compression. Okay, you can see the shape how it is changing. Okay, and the third one we have the final punch and the die closure. The moment you have to make it high, force, the maximum force you have to apply, so that it will cover everything, but there will be no flash. Okay, fine.
So one doubt.
Yes, sir.
Yeah.
Sir, every metal, every substance has some elasticity. So to overcome that, how much time do we have to hold it in the final state?
Yeah, so that depends upon you, na? That depends. So initially, maybe I wrote somewhere also, you can see. If the starting blank is too large, okay, so that depends upon your, the die size and your material, your sample, everything that depends. So if the starting blank is too large, for example, we do not know what is this size now. Okay, if this blank, for example, you are applying, let's say 2 Newton here. Okay, but if this blank is too high, maybe you can little extend of this size or the blank up to here. Then you have to apply more force. So it is written, excessive pressure may cause a damage to die or the press. You have to die to the limit. And if this is automatic, then probably you have the sensor there. Okay, so it will make a siren or maybe alarm there. But if you are applying, if this is manually or you are applying much more pressure, then you have to you have to find some die damage. Maybe I will give one more experience example in Koini, because I was working there. Okay, so I will share one more experience. The similar thing. If your material, let's say, that's why I'm talking about, if a soft material you have, aluminum, so your giving pressure will be different. But if you are applying tungsten or maybe titanium, the hard material, so your force will be different. Okay,
No, sir, I'm
because
not
everybody's,
asking for the force,
yeah.
sir. I'm asking when the force is removed, whether the material, the finished part, experiences some elasticity and regains or tries to regain some its original shape. In that case, the dimensions would differ a bit.
No, if this is elastic material, then it's, but we are not working on elastic material. This is plastic deformation. We are talking about only plastic deformation. We are not working on elastic deformation. If you
No,
see
but
the
sir,
stress strain curve initially in the beginning, So elastic part will be in the beginning. Then you have to go for plastic. So this is only we are talking about the plastic deformation, right?
Okay, sir.
Okay. So you can see the stress strain diagram in the beginning. Okay, if it is in elastic, then probably we'll find. For example, lot of material we have. So probably we cannot make it. Then there is no meaning of the plastic deformation or the, if you take the elastic material. We will not find anything. Only we have to waste the force, energy, everything only we will waste. Fine. Yeah.
Yes, sir.
Yeah. So here actually I will say, this one important also I mentioned here. What I told here, because of the special demands made by the flashless forging, the process lends itself best to part geometry that are usually simple and symmetrical, and to work materials such as aluminum and magnesium and their alloy. Okay, again I have added here magnesium. So whenever you have a soft kind of material, so your force is one different. We are talking about, please remember again, we are talking about plastic deformation only. We are not talking about elastic deformation. Okay, so that part already you have in module one, no, in module one not. You have finished in material science and technology, the elastic or maybe strength of material. Okay, the elasticity, then elastic behavior. We are talking about only the plastic deformation. And here also two important things. One is depends upon the material. Everywhere this depends upon the material. If you have the magnesium, okay, so your force will be different. If, for example, you are taking the same die or the same size of material, if you are taking one, you can take the magnesium, one you can take the tungsten. Okay, both will be different. Whether in magnesium you have to apply less force there because it is soft material. But whereas if you work with tungsten, you have to apply a higher force because this is a hard material. But of course, also you have to think about how much force actually I will apply. There should be some limit. So if this is automatic or maybe computerized, then there should be a bar there, or maybe there should be some alarm there, so that you have to go there. For example, whenever you are giving the pressure in the your car, so after some limit, for example, you are fixed it, let's say 30, so it will stop there. Okay, it will not go beyond that. So we have a digitalized now. So if you think that we have to apply for magnesium, let's say 5 Newton or maybe 10 Newton, so you have to set this bar initially. Okay, so the flashless forging is often classified as a precision forging process. Also, what I told in the last, the technique. Also, you can make is a precision forging. The moment you have the precision forging, how actually you will make. So one simple example, we have the coining. Whatever the coin materials you are using, or we are using in the wallet, or we are keeping this one. The coining is a special application of closed die forging, in which the fine details in the die are impressed into the top and bottom surface of the work part. Okay, so here you can see. So this is actually the starting blank, or maybe this is a very thin sheet. Maybe I do not know whether if I have, because I was working in that this normally when the coins and the currency actually we are preparing in Government of India. So we have several mints in India. Okay, do you remember? Do you know how many mints we have? Mint, where we are preparing the coins and the currency note. Do you know? Anyone? No or yes?
No, sir.
No? Okay, fine. So we have basically 4 mints in India. Okay, one is in Noida, and one is second one is in Hyderabad and Mumbai and Kolkata. Okay, 4 mints are there. Okay, if somebody is from that area or something, maybe you can just make an inquiry, or maybe you can find from internet as well. Okay, so 4 mints we have, but also at the same time we are before minting the coins, we are taking the blanks from the outside vendor, for example, Jindal, or maybe any steel plant, the government steel plant, or also we are preparing the blank there. Okay, for example, in Mumbai or Kolkata, we have also the blanking unit. Okay, wherever they have very thin sheets, and that sheets actually we have some punch here. Okay, this is not only one punch. This is several punches are there. Okay, here also several punches are there. So whenever this material or the very thin sheet, the coin size, for example, 2 millimeter thickness, or maybe maximum 2 millimeter, I think 2 millimeter or maybe 1.5 millimeter thickness, the sheet is actually moving here. The sheet is moving. Okay, and these 2 punches, the upper punch and the lower punch, this is not fixed there. The 2 punches, it will go up and down. So this is up and down, up and down. So the moment it is up and down, so that sheet is not only one line. This sheet is, I think, maybe half meter probably width, half meter width. and the seat is moving. So whenever you are punching in both the sides, so you will find the blanks here, small coin blanks, and whatever the waste, actually it will go like a circle. Okay, and if you have a melting unit, that whatever the waste circle or the waste seat actually we had, the waste seat again you can send to the melting furnace. Again, they can prepare some with rolling or with the slab preparation. Then again, they can prepare some seats. Again, that seat you can use here. Okay, this is only coining. Minting is different. I'm not talking that minting, only coining. So similarly, this first step is start of the cycle. The second one is the compression. You are compressing both the die. Both the die it is moving. So you have the compression now here. And the third one you have, this is removed. And the moment you will remove, so you will find this kind of small coins. Okay, and sometimes also we have, because sometimes whenever we are buying the seat actually, so sometimes this is not flat. Of course, this is flat. Somewhere this is not flat. So they have some automatic equipment, or maybe the measurement equipment or measurement tool, so that this small piece also, the small blanks also, they have to check whether this thickness is correct, whether the flatness is there or not, whether the diameter is same or not, they will check. But this is automatic. The moment they will check it, then it will go for the packing unit. Okay, like some bags, they are maybe 100 pouch. Initially, they will prepare some pouch, 100 pouch in 100 pieces in one pouch. Then maybe 100 pouch, then will be in one bag. Okay, then it will go to the minting unit. Then they will mint there. So after that, it will go to the store. Then from store, they will send to the RBI, Reserve Bank of India. Okay, so these are known as the coining, and this is also one kind of precision forging process, right? Okay.
Yes.
Yeah. So next one we have talked about the three kind of forging process. So now we have to think about the forging equipment. Okay, maybe 2-3 slides we have, then we can stop. Forging equipment. Okay, so the first part of when we talked about the forging dies, then hammers and press, we have talked in the beginning, basic forging introduction. So here you can think about the equipment used in forging consist of the forging machines, classified as hammers or press, and the forging dies, which are the special tools used in these machines. Okay, so we have to think about the hammers or the presses, and second one is dies, because two things are important. One is the press, whenever we are pressing, and second one is the dies. Okay, the two things are important. In addition, auxiliary equipment is needed, such as the furnace to heat the work. Okay, so these are also important, but these are the auxiliary. If we will talk about the primary things, one is a hammer or the press, and second one is forging die. Okay, without this you cannot do it. Apart from this, also some of the secondary or maybe some of the auxiliary equipments you need. One is furnace to heat the work, second is mechanical devices to load and the unload the work, and third one we have the trimming station to cut away the flash. Okay, so these are also some parts. For example, if you, I do not know, maybe if we have a chance, probably, because when we will come back, maybe we will see if any hot rolling mill, if we can visit maybe very close to Chennai or maybe somewhere, maybe we can think of, so that we can go maybe in the morning around 10 o'clock. Then maybe we can come back maybe by 2 or 3. This depends upon our schedule. Okay, so that means we have to think about the furnace, so whether this material you have to heat it. Okay, for the heat treatment purpose. Then second is the mechanical device. Whenever you are loading and unloading, that part also you have to think. And third one is whenever you have the flash material, you have to cut it, because you cannot keep it for long, because you have to remove that one. And the forging hammers operate by applying an impact loading against the work. So if you will see the schematic diagram here, the details of a drop hammer for impression die forging. Okay, so you can see here, these are already, I think this kind of structure we have already talked in machining already. Okay, so here this the bottom part is known as the anvil, and this is the ram you have here, and these are the frame, and this is the piston rod here. Okay, and this one is the head. Okay, it is controlling, or it is holding for all the parts. So this is known as the head, this is the piston rod, and this is the frame you have. This one is frame, and this is the ram here in between, and this is the bottom part is known as the anvil. Okay, so the term drop hammer is often used for these machines owing to the means of delivering impact energy. Drop hammers are most frequently used for impression die forging. Okay, so these are already, the upper portion of the forging die is attached to the ram, and the lower portion is attached to the anvil. Okay, so these are already so I will not go in detail, just you can read whenever you have free time. Okay, and then the drop hammers, whatever the drop hammer I told you, it can be classified as a gravity drop hammer and also the power drop hammer. Two things are there. One is gravity drop hammers, and second one is power drop hammers. These are also like, I'm not telling that you have to remember everything, but if you draw any kind of a schematic diagram, because when you will draw something, it will you can remember for a long time. Okay, so you can tell that the drop hammer can be classified two ways. One is gravity drop hammers, and second one is power drop hammers. Gravity drop hammers achieve their energy by the falling weight of a heavy ram. Okay, so whereas the power drop hammer is accelerated the ram by pressurized air or steam. Okay, so this is the basic two difference whenever we are comparing the gravity drop hammer and the power drop hammer. Similarly, the forging presses also, it apply the gradual pressure rather than the sudden impact to accomplish the forging operation. Okay, so maybe I think somebody was asking that the force whenever you are applying. So this force also, you cannot think that immediately I will just press. Everything you have to make it gradual, or you have to give the slow pressure, or maybe the required pressure or the limit pressure. You cannot make it too fast. Sudden. So that's why I told sometimes when you are making the heat treatment, this is for every case. I'm not only giving whenever you are applying the force. So also sometimes we have in heat treatment also, I told several times, whenever you are increasing the temperature or decreasing the temperature, you have to think about, or you have to control the rate of heating or rate of cooling. Okay, that is important. But there are some furnaces. I'm not telling this everywhere case. Some furnaces are there. For example, you have a laser heat treatment furnace. If in that furnace, if you will increase the temperature or cooling the temperature at a slower rate, maybe 2 degrees C or 3 degrees C per minute, that equipment will damage immediately. So in that laser heat treatment furnace, you have to increase the temperature 50 degrees C per minute minimum, or maybe 100 degrees C per minute minimum. And sometimes also I remember when I was doing this kind of work, if 1000 degrees C, if I want to increase the temperature, maybe within 3 minutes or 5 minutes also you can increase. Then this furnace will work well. But if you will take a normal furnace when we are taking or we are heating, then maybe 2 degrees C. So if I will take it to 1000, maybe it will take 4-5 hours, or maybe 7-8 hours it will take. But otherwise, that laser furnace, if you will make it, then within very few seconds, not seconds, maybe 5 minutes or 10 minutes, you can fix it so that it will increase the temperature up to 1000 or maybe 1200, depending upon the capacity of the furnace. And also one more good thing, that is we call precise. Another thing that in that laser beam furnace, there is a particular area, for example, 10 centimeter to 10 centimeter, your heat treatment zone. But in a normal furnace, you cannot find that zone, because your thermocouple will be in the outside. Okay, so the thermocouple is outside to the chamber. So the chamber is very big. So you cannot control the temperature there. So you have to insert one more thermocouple to that near to the sample. I told several times this one, so just you can remember. So similarly, in the forging process also, you have to increase, or you have to give the pressures gradually or slowly according to your requirement. And the forging press include mechanical press, hydraulic press, and the screw press. Three things are required. So one is mechanical press. It operates by means of the eccentrics, cranks, and the knuckle joints. Okay, so these are also, And the hydraulic press uses a hydraulically driven piston to actuate the ram. And the third one, we have the screw press. This apply force by a screw mechanism that drives the vertical ram. Okay, so maybe if you remember in machining, I think we have done a few work on this one, and also we have shown in when we have finishing one, you have talked about the mechanics of machine, and second one is machining. In both these subjects, I think you have already covered the mechanical presses, then hydraulic press, and the screw press. So I just put one definition there, how you can differentiate all the three. Okay. Yeah. So next one, you have the forging dies. Okay, so maybe two slides. Only this slide is important. You can see here. So you need the forging dies. Okay, so that's why I told in casting, or maybe here in machining, whenever you are talking about the forging dies, also you have to think about what kind of die you are considering in the beginning. So it is mentioned that the proper die design is important in the success of a forging operation. So you have to design your die in the beginning, then only it will be possible. Because if your design is not good as a mechanical engineer, or maybe when you are thinking about the designing process, you have to design it properly. If you not design, then probably it will not work. Okay, so the parts to be forged must be designed based on knowledge of the principles and limitations of this process. So you have to understand what are the basic advantages of this, or what are the basic limitations of that particular materials also. Because whenever you will prepare a die, or maybe when you will design a die, then also you have to think that which kind of material I will put there. Okay, all the parameters you have to think. You should not think about only one parameter or two parameter. And the design of open dies is generally straightforward because the dies are relatively simple in shape. So sometimes we are considering these are very simple, so we can make it easily. But also at the same time, you have to think very carefully. You do not take it, everything you have to do very coolly or very in a systematic way. But at the same time, also you have to think very properly. Okay, and we indicate some of the principles and the limitations that must be considered in the part design or in the selection of forging as the manufacturing process. If you remember in NPD, when we have talked about, I do not know, maybe few students were with me. So in when we are talking about any product development also, you have to design in the beginning. Okay, of course, the marketing part, you can just forget about whether you will sell or not, whether people they will buy or not, that is different part. But the designing part, initially you have to think what I will do, what material we will put, then what should be the limitations there? What should be the limitations? You do not know, but you are predicting that, or you are thinking that maybe this kind of problem can arise. Okay, then also you have to keep in mind. For example, when we have the cyclone or something, we are thinking that probably this can be happen. So for that we are preparing, in the beginning. So similarly here also you have to think that if we are putting a magnesium metal or maybe any titanium metal, so probably this kind of problem can occur. Okay, so here you can see all the terminology I just mentioned here. So one is this part is a rib, and this is the corner, and this is the fillet, and this is the web, and these are the the flash. Okay, and sometimes also you have to think about the flash, whether you have to, if your design is like this, or if your mold is like this, or if your dies are like this, then also if you need this flash, then you can keep it. For example, sometimes we are making different structure or different shape near to the outside. Okay, so maybe we are calling this as flash. If you do not want, you can remove it. But if this is required for according to your dies or according to your mold, also you can keep it. There is no harm. Okay. Okay, and this is the upper die you have, and this is the lower die. And normally this, whenever you have the center or maybe and the separating the upper die and the lower die, we are calling this is putting line. Okay, so all the terms I have mentioned here, one is putting line, and second one is the flush line, and the third one we have the draft, wave, and then fillet. Only whatever I explained, these are everything I just mentioned here. Just you can have a look or cross check. Okay. Yeah. So yeah. Yeah, any questions from your side?